So 2-1, we talked about the definition of a parallelogram and the properties of a parallelogram. So let's go through all of them, including the definition. Properties of parallelogram. What's the definition of a parallelogram? Yeah. Good. Not congruent. Nope. Parallel. So they do have that, but that's not the definition, right? This would be the definition. Okay? The quadrilateral with both pairs of opposite sides parallel. That's the first thing we know about parallelograms. What's another would be, I'll go with yours, Jonathan. Both pairs of opposite sides are? What'd you just say? Good. Are congruent or equal. Okay, what's another thing, Santi?
Not every angle is equal.
No, but that's not a property of it. They could, all angles could be equal, because one that has 90 degrees would still be a quadrilateral. That's a parallelogram. So it could happen.
So square is a parallelogram.
Correct.
No?
You just say no. You just fast forward until when we come back from break what we're learning. Yeah.
Consecutive angles equal or supplementary.
Okay, so consecutive angles. Are supplementary.
Yay.
What else? Go ahead. Opposite angles are congruent. What else? Yeah.
When you draw a line from each opposite angle, they bisect.
So diagonals bisect each other. Good. Okay, so those are all properties. The one at the top would be the definition, which is that both pairs of opposite sides are parallel. Then both pairs of opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, and diagonals bisect each other. Because everything that's there today, we will reverse, and using those to prove that a quadrilateral is a parallelogram. So these are, of course, these are obviously things that we need to know. And then we apply them to stuff like this. So number 1 says to find the values of A and B in the parallelogram. You're dealing with both sides and angles, right? So these opposite sides are congruent, which means A minus 12 would equal 30 and A equals 42. And then these opposite angles are congruent. B plus 10 equals 36 and B equals 26.
Nice.
Questions on that one?
What game is that?
2, find the measure of angle K in the parallelogram. So the only angle we currently have the measure of is L. What's the relationship between angle K and angle L? Good. So 64 plus the angle that is K would equal 180, or 180 minus 64.
116 degrees.
Good. Is K, which would also be M, and J would be what? 64. Good. So if you have one, you can find all 4 in a parallelogram.
Is it the same for would you use some of the, oh wait, no.
You sure?
Yeah, I was going to say the 2 parallels.
That's where it comes from. Yep, so this is the parallel line. This is your transversal. Those would be same side interior or consecutive interior, which are supplementary.
Would you use alternate interior?
If you had one on the outside, or on this side, like if you were looking for this angle, yes. More often than not, you'll see the alternate interior with the diagonals, because that happens inside. Marcia, you had a question or no?
Are we doing the next one?
Yep. All right, 3 and 4 say find the indicated measures in parallelogram ABCD. So in the instructions, it tells you that it's a parallelogram. So BCD is this whole angle, right? How do you find it?
So basically, angle ABD is the same as angle BDC, so the one right next to 37. So that whole angle D is 137.
Okay.
And then since
So would this be right? This would also be 30.
Supplementary, then you have to subtract 180 from, or 137 from 180, and then Angle C is 43. Unless I did that wrong.
No, that's right. Good job.
I messed up the little things. That's fine.
Number 4 says BE is 9. God bless you. BE is 9. Find BD.
I'm only here for a test.
Thank you for sharing. Thank you for sharing. What is BD? 18, right? Because this diagonal would be bisected or double it, and you get 18. Questions?
Easy.
All right, so 7.3 is proving that a quadrilateral is a parallelogram. So we're going to use the All right, so all the things that we know about parallelograms that make it a parallelogram is what's going to now flip-flop it and go from quadrilateral to parallelogram. The first is if both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. So we basically just came up with the converse to the theorem we learned yesterday.
Parallelogram.
If both pairs of opposite sides are congruent, then the quadrilateral is parallelogram.
Wait, so what form is it?
If it's a parallelogram, then the sides are congruent. Correct. So this is the parallelogram, opposite sides, converse. Parallelogram, opposite angles, converse, which says if it's a quadrilateral, so it's got to have the 4 sides. If it's a quadrilateral with both pairs of opposite angles congruent, then it's a parallelogram. Then there's a combination of ones. So this it puts 2 together, which says if you have one pair, and it has to be the same pair, so the same pair of sides are both congruent and parallel, then it's a parallelogram. So this is not a converse because it didn't have one in the original. This says the opposite sides, parallel and congruent theorem. Again, sometimes the wording on the title of your theorem is longer than just saying if one pair is parallel and congruent, then it's a parallelogram. Back to the converse, parallelogram diagonals, converse says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if this is cut into 2 equal pieces and this is cut into 2 equal pieces, then it's a parallelogram. All right, so there are 5 ways to show that a quadrilateral is a parallelogram. The first, we only wrote just 4 just now, but the first is because of its definition. So the first is the definition of a parallelogram, which would be both pairs of opposite sides are parallel. So you could literally, you don't have to, that is the most chicken scratch thing ever. Definition of a parallelogram. Maybe I should try to use my finger instead of the pencil. All right, so that you could literally write out both pairs of opposite sides are parallel, or you could write, if you wanted to give a reason, the definition of a parallelogram. Just like the rest of them, you can write out the name of the theorem or converse, or you could write out the reason. Both pairs of opposite sides are congruent, which was the parallelogram, opposite sides, converse. 3, show one pair of sides are parallel and congruent, which is not a converse because we didn't have that before. That's opposite sides, parallel, and congruent theorem. Opposite sides, congruent, and parallel theorem.
I can breathe.
4, both pairs of opposite angles are congruent. This is the parallelogram, opposite angles, converse. And the diagonals bisect each other. This is the parallelogram, diagonals, converse. All right, so again, this is what we just wrote. Both pairs of opposite sides are parallel. Both pairs of opposite sides congruent. Both pairs of opposite angles congruent. One pair opposite sides are congruent and parallel, and diagonals bisect each other. I don't want you using the numbers, though. You can give the name or you can describe it, but I don't want you using the numbers. All right, example 1. State the principle, definition, or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. So 1 says BE is congruent to ED and CE is congruent to EA. What reason would that be?
Ooh.
Yep.
The diagonals both bisect each other.
Okay, so diagonals bisect each other. I'd rather you not stress about the number because I don't want the number, right? Diagonals bisect each other, or the parallelogram diagonals converse. You got to make sure you use converse here.
I'm gonna just put that bisect each other.
Well, it's really if diagonals bisect each other, then it's a parallelogram because it's got to be the converse. 2 says it's the diagonals. No, it's the parallelogram diagonals converse.
What's the theorem?
The parallelogram diagonals converse.
Wait, when is the quiz?
I thought you were going to ask me the same
Tuesday?
question. Yes,
It's the Tuesday we get back.
Parallel diagonal converse.
correct. Parallelogram diagonals converse. Okay. 2 says angle BAD, which is this angle here, equals BDCB, which is this angle here, and ADC equals CBA. So, Kumar. Parallelogram, opposite angles converse, or if opposite angles congruent, then it's a parallelogram.
I remember that one.
Yeah.
Ow.
Okay, 3 says BC is parallel to AD and AB is parallel to DC. What reason is that? Nick.
The opposite sides are parallel.
Okay, if opposite sides parallel, then parallelogram, or this is the one that's short because you can say definition of a parallelogram. That's not a theorem. Okay, that's a definition.
Nice.
4
BC equals AD and AB equals DC.
So that shows that both pairs of opposite sides are congruent.
Good. If opposite sides congruent, then parallelogram, or what's the name? Parallelogram, opposite sides converse. Okay, last one, BC, well, let me erase what's there. Oh, man, I just wrote over it. BC, AD, and BC, AD. Congruent and parallel. Kumar.
Shows one pair of opposite sides.
Kumar, did you just make your voice come out of him? Good job. Like a what is it called? Ventriloquist? Okay, one pair. Opposite sides, congruent and parallel, or what's the name of the theorem?
Opposite sides parallel.
Opposite sides, parallel and congruent. And again, this is the theorem, not the converse. That's the only one that's not a converse. So how you choose to give that doesn't matter. I think on the big ideas, it's like the drag and drop, where you have to like pull in the reason, so you wouldn't have to write it all the way out. Questions on those? All right. For what values of x and y is the quadrilateral a parallelogram? So if this was a parallelogram, what would have to be true about your opposite sides? They were
equal x, congruent.
They would be congruent. So we just reverse it. We say if these were congruent, if x plus 9 equals 2x minus 1, and then solve. So if x is 10 and y would have to equal x plus 7, which means y would have to equal 10 plus 7. Y would equal 17. So only if both those are true is this a parallelogram, because then the opposite sides are congruent.
Oh, that's pretty easy.
wanna breathe.
Questions on that one?
So, is our homework assignment gonna be due Monday?
Like the Monday we get back. Yeah. 3 says for what values, oh, sorry, Cal. All right, for what values of x and y is the quadrilateral a parallelogram? So what would be true about these angles? And there's 2 relationships you could set up, but only one in this case is going to help you solve it, which would be what? Kumar. Good. So because the same variable is opposite, I would use that one. If it was x and x consecutive, now I would use that they are supplementary, okay? But because the x's are across from each other and the y's are from across from each other, I use opposite angles are congruent. So 3x minus 32 would equal 2x. Subtract. Thank you, Mars. X is 32. And then 4y equals y plus 87. Subtract the y. 3y equals 87. Divide by 3. And y is 29. So again, if it was the x's were consecutive, I would use the supplementary property. Because these are opposite, we use the opposite one. Hold it together a little longer. Just a little longer. Questions on that one? Okay, last one. So in this proof, you're given information and you're trying to prove that the quadrilateral is a parallelogram, which means you're using one of your 5 methods. Opposite angles congruent, opposite sides congruent, opposite sides parallel, diagonals bisect each other, or opposite side, one pair of opposite sides are congruent and parallel. If you look what's given, you don't have any information about the sides. So you could literally narrow down all those choices to like half because it's only things about the angles, right? What the given information is that ADB, which is this one, is congruent to CBD, which is here, and ABD is congruent to CDB. So how does that information help us? Jonathan?
I was going to say that DAB and BCD equal each other because of the definition of parallelogram.
So you don't know it is yet a parallelogram. You have to show it's a parallelogram. Yeah.
Can't you do angle ABD plus angle ADB equals angles CBD?
Like the angle addition postulate is what you're doing? Yeah, but that's only going to get you one pair of opposite angles congruent, right? They both have to be.
Does
So-
that have something to do with the diagonal?
No, I mean sort of, but not the length of the diagonal. There's technically 2 ways to do this, but the easiest way is, can I prove those sides are parallel? How?
Yeah, you can.
Good. So if these are a pair of sides and this is a transversal, if this is congruent to this, then I can say AD is parallel to BC, and that's the alternate interior angles converse. And with that same reason, if these 2 are congruent, then these 2 are parallel. AB is parallel to DC. Same reason, so I could keep it in the same step. And now I have both pairs of opposite sides parallel. So is that enough information to prove it's a parallelogram? Yep. What's the reason? Definition of a parallelogram. So you could have, Kala, you could have kept going with angle addition postulate and proved that this one was equal to this one. But then you'd use third angles theorem to prove that the remaining angles are equal to each other. And then you'd have both pairs of opposite angles are congruent. This is just a little bit easier, but both would work. Questions? Okay, that's it, folks. You've got 15 minutes, 16 minutes to get a head start. Not even playing your game. -2, -4 was D. 0, 7 was F. 1, 0 is G. Okay, and D connects with G, and G connects with F, so E has to be somewhere over here. 1, 2, 3, 4, 5, 6, 7. Shh, guys, back one. 1, 2, 3, 4, 5, 6, 7. Back one. There's your negative 3, 3.